Hello, my lovely students. In this series of videos, we will explain this book, which is Cambridge Lower Secondary Mathematics. And in these videos, we will talk about the ninth grade book. In the very first section, which is section 1.1, the title is Irrational Numbers. In irrational numbers, in order to get familiar with them well, we have to know the rational numbers as well. And here we have the keywords irrational number, rational number, and there is another new word, which is we call it third. So during the questions, I'm going to define this word and what is the relation between this word and our lesson. Well, here I would love to mention some kinds of rational numbers. The first one is all the natural numbers are rational numbers. So what are the natural numbers? They start, according to some books, they start from 0. According to some other books, they start from 1. So in this book, according to this Cambridge book, it starts from this set of numbers, which is natural number, they start from 0. So 0, 1, 2, 3, 4, and up to infinity, we call them natural numbers. The second type of rational numbers are integers. So integers are all the natural numbers and their negatives, their opposites, which means from 0 to positive infinity, and also -1, -2, -2, -3, till negative infinity. We call them integers. All right, and the letter that represent integers, according to some book, it's Z, or sometimes we show them with I as well. But mostly, I have seen that this set of numbers are shown by the letter Z. The third type of rational numbers that we must know in order to not face any difficulty during the the exercises, we have to know them, is the set of perfect square roots. What are the perfect square roots? They are like kinds of number that they made up of the multiplication of a number by themselves. For example, square root of 1, it is perfect. Why? Because it comes from 1 times 1. Square root of 4, it is perfect. Why? Because it comes from the multiplication of 2 by 2. 9 is 3 times 3. 16 is 4 times 4. 25 is 5 times 5. And the next one is 36. Then we call this set of numbers perfect square roots. And they are all rational numbers. The fourth type of rational numbers are perfect cube roots. So the symbol that we show with that is something like this. So perfect cube means the index must be 3, but as you can see for square there is nothing. So because they start from 2, since they start from 2, so we are not going to write anything here, because in fact it should be 2 here, but no need to write these two. But for the cube, we have to write it down. So how do we read this one? Cube root of 1, cube root of 8, cube root of, if you go and check it, you are going to see how did we got these numbers, and I will mention some of them. Cube root of 27, cube root of, don't forget about this index, cube root of 64, cube root of 81. All right, so how did we get these numbers? For example, 1 is equal to 1 times 1 times 1, 3 times by itself. So for the square, it was only 2 times, but for the cube, we have to multiply the base by itself for 3 times. And cube root of 8, it is 2 times 2 times 2. Or for 27, it's 3 times 3 times 3. For 64, it is 4 times 4 times 4. For 81, Actually, it's not 81, so the next one is 125. So it is 5 times 5 times 5. So the next one is cube root of 216, which is 6 times 6 times 6. And the next one, let's just mention them. They are not a lot that we need in this book. Cube root of the next one is 343. So it is 7 times 7 times 7. And the next one is cube root of 512, which is 8 times 8 times 8, 3 times, because it's cube. And not the last one, the one before the last one is just 729, which is 9 times 9 times 9. And the last one is the famous one, which is cube root of 1000. It is equal to 10. So perfect cube roots are all rational numbers. The fifth type of rational number are two types of decimal numbers that we call them terminating and recurring decimal numbers. What are the terminating what kind of numbers are terminating decimal? Like a decimal number that it has got like an ending digit, it is a terminating decimal number, and it is always considered as a rational number. For example, 2.3. So there is an ending digit, which is 3. So it is rational. What about negative? Negative and positive will not make any change in order to being rational or irrational. So negative 7 point, let's say 156. So the ending digit is 6. This decimal has ended already. That's why it is a terminating decimal number. What about recurring decimal number? So recurring decimal number, according to the local book, we call it repeating decimal number. A decimal number like 6.444, and it goes on up to infinity, which means this digit of 4 is repeating up to infinity. So we call it a recurring decimal number, and it is always rational. So terminating and recurring are always rational numbers. What about six types of rational numbers? According to the definition of rational number, it says any number. So here is the definition of rational number. Any number that can be written as a fraction is a rational number. It is a rational number. Something like as a fraction like a over b, while b cannot be 0. So the denominator should not be equal to 0. In that case, if it is 0, it will be undefined. So based on the definition of rational number, we can define the 6 types of the rational number. So all the fractions, proper and improper. Okay, all the fractions are rational number. For example, 3 over 2 or 2 over 5 or negative 1 over 16. These are all rational numbers. So again, I'm going to repeat them. All the natural numbers, all the integers, all the perfect square roots, all the perfect cube roots, all the terminating and recurring decimals, all the fractions are rational numbers. And I would like to make you sure, like for 100%, that these are the only types of rational numbers that you need during this book. During the exercises, you will face them a lot. What about irrational number, guys? So irrational number. What are the irrational number? If a number is not irrational, it is going to be irrational. For example, we can say the first type, not like imperfect square roots. Like the second type is imperfect cube roots. Example for these two, like it can be square root of 2, square root of 3, square root of 4 cannot be, because 4 is perfect, so therefore it's going to be rational. Square root of 5, square root of 6, square root of 7, square root of 8, and it goes on like this. Square root of 9 is rational because it is perfect. What about imperfect cube roots? For example, cube root of 2, cube root of 3, cube root of 4, cube root of 5, cube root of 6, and these kind of cube roots are imperfect. Since they are imperfect, they are going to be irrational. All right. The third type that we need to know is just those decimal numbers that endless, that they are endless. So endless decimal numbers, such as like, let's say the book will show it in this way, like for example 2.175, and there are 3 dots here. So we call this kind of numbers not terminating decimal, so they are considered as an irrational number. All right, so let me just make some difference between two types of number. For example, if you have something like 3.555 and then 3 dots, and then what if we have something like 3.657, then 3 dots? In both cases, we have dots at the end, so it means they are endless. But this one, since the decimal digit is repeating, so it is recurring. Therefore, it is rational. All right. But this one, since the decimal digits are not the same, and it is endless, so there is no end for this one, so it's not terminating. Therefore, it is going to be irrational number. Irrational number. That is all about rational and irrational number. I hope that, guys, you can just rewrite this page and stop the recording for some moments and rewrite this one in one paper, or prepare a notebook beside yourself and write exactly what am I writing in the video, because based on this, be 100% sure that you can solve the questions completely. Here there are two notes, two tips. The first one said the set of rational numbers includes integers. We already mentioned the types of the rational numbers. The second one was integers. Square root of negative numbers don't belong to the set of rational or irrational numbers. You will learn more about these numbers if you continue to study mathematics to a higher level. But right now I can give you a hint regarding to this note. For example, square root of negative 4. It is different than square root of 4. Square root of 4, it's positive inside, so it's equal to 2, right? And there is no problem with this one. But this one, according to this tip, and as this tip said, in the higher level of education, you are going to study this and like what type of number is going to be. But for now, the thing that you need to know, if inside the square root is a negative, it's neither rational nor irrational. So it's none of them. All right. So let's discuss about some of the questions here. The first question, like in page 12, it says write whether each of these number is an integer or an irrational number. Explain how you know. So like I can say instead of this integer, we can say rational, okay? Because integers are rational. So which one is rational? Which one is irrational? Square root of 9. If you go back to the explanation, we said square root of 9 is perfect. Therefore, it is going to be rational. Square root of 19. There is no number that if you multiply by itself gives you 19. That's why it is irrational. All right. Square root of 39. If you go and check it, you cannot find a number that if you multiply by itself gives you 39. Therefore, it's going to be irrational too. And square root of 49, it is one of the perfect square roots. How do you know it? If you go and times 7 by 7, you are going to get 49. So it is a perfect square root. Therefore, it is integer and rational number. But what about the last one? I will just leave this one for yourself as an homework. So you can check it by yourself. It is easy. If you could find a number that if you multiply by itself gives you 99, it's going to be rational. If not, so it is going to be irrational. What about the second question? It says, question 2, write the rational number in this list. Only the rational number. So let's just find out which one is rational, which one is irrational. Square root of 1, it is one of the perfect square root. That's why it is rational. The second number, it is a mixed number. So here I would love to add one more type of like square rational number. We can say here, we can add this one, all the mixed numbers. All the mixed numbers are also rational numbers. For example, like 2, 3 over 5. This is what we call mixed number. So, okay, a mixed number contains like a whole number and a fraction. So all the mixed numbers, no matter like they are positive or negative, they are rational numbers. That's why here, write the rational number in this list. So perfect square root of 1, it is perfect. So it is rational. Like the second one is, mixed number, so it is again rational number. The third one, it is an integer, a negative number, so it is rational number. The second one, the next one is square root of 160. So 160, if you go and check it, it's not perfect because you cannot find a number that if you multiply by itself gives you like 160. Therefore, it is irrational number. The next one, like sometimes I see that students have problem with this type of questions, like square root of 2.25. So forget about the negative because negative doesn't make any change. So 2.25, if you go and check it, 15 times 15, it is equal to 225. Now if we have 1.5 multiplied by 1.5, so if you multiply them by each other, so it's going to give you 2.25. So if you get like if you take square root for both sides, it will give us something like this, like the square root of 2.25, it is equal to negative, this negative refer to this one, negative 1.5. Therefore, since it is perfect, since there is a number that if you multiply by itself, it will give you the inside of square root, it is rational number. All right, because at the end we are going to have a terminating decimal. The last one, as I already mentioned, forget about the negative. Square root of 35. Is it perfect or not? Go and find it out. Part B, write the irrational numbers in this list. So the first one, as you can see, the digit 3 is repeating. Therefore, it is recurring decimal. So recurring decimal is rational. The second one, it is an integer. It's a negative number, so it is rational 2. The third one, square root of 200, it's not perfect. If you go and check it, you cannot find a number that if you multiply by itself, it gives you 200. You might ask me, teacher, what about 10 times 20? Okay, 10 times 20, I know that it is equal to 200, but the problem is they are not the same. We said that a perfect square root came from the multiplication of a number by itself, right? The next one, it is something like this question. So I would love you to go and find it and try your best. Find a number that if you multiply by itself, it's going to give you 121. But if you go and find the decimal version of it, you will find it out. So the third one, the next one is a fraction. All the fractions, don't forget, fractions are itself, like themselves, like they are the definition of the rational numbers. All right. Sorry, I think there was an interruption. That's why I'm sorry for that. So we are gonna continue from here. So perfect cube root of 343 is a perfect cube root, because here, if you go back to the explanation, you're gonna see that one of the perfect cube root is like 343. It is equal to 7, so it is rational. All right. Perfect. And here, write whether each of these numbers is an integer or a third. So third, guys, it means irrational. So the word third means irrational. All right. So explain how you know. Square root of 100, is it rational or irrational? It is definitely rational, because if you go and check it, you will see that 10 times 10, it's 100. So square root of 100, it is equal to 10. So listen to me carefully. 100 has perfect square root, but 100 doesn't have perfect cube roots. That's why square root of 100, it is rational, but cube root of 100, it is irrational, because you can't find a number that if you multiply by itself 3 times gives you 100. But what about thousands? So for 1,000, it's the situation is vice versa. For 1,000, we don't have square roots, because we cannot find a number that if you multiply by itself gives you 1,000. But that's why it is irrational. What about cube root of 1,000? If you go back to the explanation, you can see that one of the perfect cube roots is 1,000. Therefore, the cube root of 1,000, it is rational. For 10,000, I want you to check it by yourself, because I will leave some question as an homework for you. Guys, is each of these numbers rational or irrational? Give a reason for each answer. So the first one, 2 plus square root of 2. All right, 2 is rational. Square root of 2, it is irrational. So if you add them, the result is going to be irrational. All right, because you cannot find an exact result of it. What about the next one, part B? So square root of 2 plus 2. First, inside the square root is going to make 4. Square root of 4, it is equal to 2. What about part C? Part C has the same situation with part A. So one of them is rational, the other one is irrational. Rational plus irrational, the result is going to be irrational. And the last one, so it is going to make cube root of 8. So I will leave it for you, whether to find it out whether it is rational or irrational. So in question 5, find 2 irrational numbers that add up to 0. All right. So 2 irrational numbers, think about not perfect square root. All right. For example, square root of 2, if we add it to its opposite, so it's going to make 0. And this is exactly the answer of the question. It says 2 irrational numbers. So you know that square root of 2 is irrational. Its opposite also, it is irrational. So if you add them, the result is going to be 0. Not only for square root of 2. You might say, okay, teacher, can we mention square root of 3 plus its opposite? Yes, definitely. Because they are going to kill each other and only 0 will remain. What about 2 irrational numbers that add up to 2? All right. Again, there is some like tricky way to do this one. Imagine if we have square root of 5, so it is irrational, plus 2. Still it is irrational, right? If we add this one to the opposite of the square root, which is negative square root of 5. Now let me just make this one clear more. It says two irrational numbers. Find two irrational numbers that when you add them, the result gives you 2. Let's see whether these numbers are irrational or not. So the first one, it's clear that it is irrational because look, 2 is rational, square root of 5 is irrational. If you add them, the result is irrational. Alright? And negative square root of 5, it is also irrational. So if you add these two are going to kill each other and only 2 is going to remain. This is exactly the answer of the question. You might mention, like it has more than one solution. You might mention another square root, like the square root of 3 plus 2. It is one irrational number plus one more. So the other one must be the opposite of the square root. So means square root of 3 here. So that they are going to kill each other and only 2 is going to remain. So the teachers can change this number 2 to 3. Here we are in the third part of our lesson. I think I was like speaking a little bit fast. That's why I will speak a little bit slower. Without using, I will leave like this thing like a mathematician and I will leave it for you, guys. So without using a calculator, show that this square root of 55 is between these two numbers. So it is clear. You know why? Like square root of 55, you know that, let's come to here. 55, it is between two perfect square roots. One of them is less than 55, which is 49. The other one is greater than 55, which is 64. Now if you take square root for all the sides, left, right, and middle, so it's going to make 7 here, square root of 55, and then square root of, 8. So as you can see, we show it, and it is easy to show without using calculator. So we can see that square root of 55 is between two integers, which is 7 and 8. So I will leave this one for you. Think about the cube roots of 100. It is between two perfect cube roots, like 4 and 5. What was the cube root of 4? Find it out. And what was the cube root of 5? So write it here. So take the cube root for all the sides, just like this one. You are going to find out. Without using a calculator, find an irrational number between 4 and 5. So finding an irrational number, honestly, it is easy. You know why? Because so square root of 4 square, it is 16. So 4 square, it is 16. 5 square, it is equal to 25. Any square root between 16 and 25 can be an irrational number between these two numbers, such as square root of 17, square root of 18, square root of 19, up to square root of 24. Okay, these square roots are a kind of irrational number between these two numbers. So I will leave that example for you. Do something like this. Find the square roots between 12 and 13. So 12 square, let me just give you this hand. 12 square is 144. 13 square is 169. Okay. Without using a calculator, estimate this one to the nearest integer. So 190, it is between two perfect square roots. All right, one is 169 and the other one is, so 169, it is 13 times 13, and 14 times 14 is 196. So if you take square root for all the sides, as you can see, this one is 13, that one is 14. But the question is estimated. Which one is nearest to 190? The distance between 169 and 190, it is 21. But the distance between 90 and 190 and 196 is just 6. So which one is more closer to 190? Definitely 196. Therefore, if we estimate it, it's almost equal to 14. What about cube root of 190? So 190, again, it is between two perfect cube roots. The first one is like 125 and the second one is 216. So if we take cube root for all these three sides, so cube root of 125, it is 5. Cube root of 216, it is 6. But the question is, if we want to estimate it to the nearest integer, which one of these two numbers is more nearer to this number, which is 190? So the distance between these two is obviously less than the distance between these two, because here is 65, but here is 10 and 16, 26. Therefore, if we estimate this cube root of 190 to the nearest integer, it will be 6. That's all about this type of questions. So you must find out what are the perfect square root and perfect cube roots around the given number. And more clearly, if I'm gonna be honest with you, you have to get familiar with the perfect square roots and perfect cube roots perfectly. All right, just like you know your name. Use a calculator. So that is the final question that I would love to talk about it, because others just like discussion. So use a calculator to find. That is a very important question here, guys. Use a calculator to find this one, that one, and that one. Then we are going to generalize this multiplication, this product. There is a pattern. It says, like here is the pattern. All right. If you have something like this, let's come to here. Like square root of n, no matter what is this, like plus, let's say 1, multiplied by, again, the square root of n minus 1. So there is only this difference, that inside one of the bracket there is plus, inside the other one is minus. If we multiply them, so we are going to get this, square root of 1 times square root of 1. So it's gonna make one n. Square root of n times negative 1, negative square root of n. Then multiply this one also by each term. So 1 multiplied by square root of n, square root of n. Negative 1 multiplied by positive 1, so it's gonna make negative 1. Positive multiplied by negative, negative. As you can see, these two are gonna kill each other, and only what will remain? N minus 1. So we are going to use this idea to solve these three questions. Okay, here what is our n? It is 2. So 2 minus 1, it's equal to 1. What about here? What is our n? N is 3. So 3 minus, we use this idea, this rule to solve these three questions. So minus 1, 2. And here, so our n is 4. What I mean by n, look, under the square root we have n. So here, what is the number inside the square root is 4 minus 1. All right, so I would love to give you a question regarding to this matter, like square root of, let's say, 6 plus 1 multiplied by square root of 6 minus 1. Try to solve this one. Thank you for listening to me. Have a nice day, and I hope that you got benefit from the videos.